Hello there, and welcome to everyone joining us for this latest IoT Central webinar. I'm Clive Maxfield, everyone calls me Max, and I'll be your host. In addition to being a practicing engineer, I also act as a technology consultant, author, speaker, and educator. I'd like to start our webinar by thanking Spindance for sponsoring today's event. Spindance is a leading supporter of the IoT Central community, and we're grateful to have them as sponsors. Today's webinar is entitled Assessing Readiness for Machine Learning in IoT. Before we begin, I'd like to briefly review the format of today's proceedings. This event will be 1 hour long. We have one presenter who I'll introduce in just a moment, and there will be a question and answer session after the presentation. I'd also like to encourage you to use the webinar interface to submit questions throughout the presentation, and I will be presenting your questions during the Q&A session following the presentation. Now, I'm very pleased to introduce today's speaker, Ben Jocks, who is Director of Engineering at Spindance. Whenever you're ready, Ben, you can take it away.
Thank you very much, Max, and welcome everybody to today's webinar. Like Max said, we're going to be talking today about assessing readiness for machine learning, more specifically in IoT than in other spaces. So with that, we'll go ahead and jump right in. Our outline for today is going to be pretty straightforward. We're going to talk about machine learning fundamentals, just make sure we're all speaking the same language, all on the same page for what it is that machine learning is and what terms we use to talk about it. Then we're going to dive into the meat of this presentation, which is really talking about what makes machine learning projects successful or sometimes not. And that'll really be broken out into two parts. There's business contributors and there's technical contributors. And then we'll jump to one of the big questions, which is how do you actually assess your readiness for machine learning? Then we have one audience poll question that we'll have, and then there's going to be a decent amount of time for Q&A at the end. So as Max said, feel free if you think of questions during the presentation, go ahead and drop them in the chat, and we'll try to get as many questions answered as we can at the end. So when we start talking about terminology, there's a lot of different terms that people use for machine learning. Some of them people use interchangeably, sometimes they don't. Oftentimes people refer to it as artificial intelligence, which is actually the biggest, broadest definition that there is. And artificial intelligence is really just any technique that enables machines to mimic human behavior. And kind of a subset of that, machine learning, is an approach that uses statistical methods to enable machines to improve over time. And that's usually the space that I talk about the most as machine learning. I think it gives a specific enough definition, but not too narrow of a definition. And deep learning is another term that people often use. And really deep learning is just a subset of machine learning that uses multi-layer neural networks to be able to process things. And sometimes that is the right solution for machine learning. Sometimes we can use more simple statistical methods to get there. So that's kind of the broad terminology that we use, and today I'm going to use machine learning as the primary term. And when I talk about machine learning, from a really high level, I would say all it really is it's a way that allows computers to find hidden insights without being explicitly programmed where to look. So if you think about a more traditional approach to programming, usually you have some sort of data, you have some sort of desired output that you want to get out of that data. So you hire a developer, the developer looks at the data and starts to write a program that can give you the outputs that you want. If you were to use an example like trying to determine a house price based on certain factors, maybe you give some data to your developer and the developer looks at it and says, oh, it seems like when I look at house price, I think the number of bathrooms, maybe the number of bedrooms, square footage all play into this. And so they take that data, maybe they add some multipliers, they add some numbers together, and then try to give some prediction out at the end. And sometimes they'll go back and refine that program and refine that algorithm over time. Machine learning takes a little bit of a different approach where we have typically a larger input data set that's labeled with the outputs that we want out of it. We feed all of that information into a machine learning training system. And instead of a program or an algorithm coming out the end, what we get is a model. And that model can then be used to take in new data and predict new outputs coming out of it. So it's a slightly different approach to things that gives you the same end result, but has a totally different approach to how you get there. And one of the key pieces of machine learning is this data component. So having good, clean data to be able to train your model with going into it really enables you to find some really cool things without having to necessarily decide for yourself, like, oh, maybe it's bathroom, maybe it's number of bedrooms, maybe it's square footage. Machine learning model might learn, well, actually, it's more important how close or far it is from a city, or maybe square footage really does matter, or nearby house prices, or some other things, but you let it learn that instead of you telling it what to do. One of the really cool things about machine learning, and one of the things that makes it so exciting for me, is that this has really become a very disruptive technology in almost every single industry you can imagine, from manufacturing to healthcare to consumer products to agriculture, energy, science and research, as well as many others. I'm not going to go through all of these different use cases here in this presentation, but I just want to highlight a couple of them. In the manufacturing space, it's really becoming disruptive in this predictive maintenance and process optimization space. Even a lot of quality inspection now is turning toward machine learning to inspect product that was very difficult to do with traditional approaches. On the consumer product side, we're seeing a ton of new IoT devices with a lot of ease of use features. So you think about things like ambient computing, being able to use voice interaction to be able to communicate with your device and tell it what to do, or it coming to conclusions for you without you having to sift through a bunch of data. In the agriculture space is kind of a cool one. I actually did a project about a year ago where we got to look at livestock and essentially measure the health of livestock using 3D computer vision and machine learning algorithms. And it was just a really neat mixture of industry and technology that I would have never thought went together. And even before, earlier in a previous life, I worked on a pretty neat project in the chemistry space where you could actually use machine learning to start finding ways to synthesize new molecules with specific properties that you really wanted for that. So the number of use cases and the number of industries that machine learning touches is just phenomenal. And it's really cool to see those domain knowledge pieces come together with this machine learning technology to enable a lot of really cool things that companies can do with that. And when we talk about machine learning, especially in the context of IoT, a lot of times when people think of machine learning, they think of these big server rooms, these big cloud computing systems, tons of server racks, maybe these powerful GPUs that are running on your local machine. And I think one of the neatest things that I've seen in the last few years in the IoT space is how much that is now shifting to edge devices, these little microprocessors that are running on our IoT devices out in the field. This is due to just improvements in hardware, improvements in efficiency of our models, or a lot of new technology that's coming that's making models smaller. We're understanding them better and being able to push this logic down to our devices, which is really, 5 years ago, I would have never thought that was possible. And now I'm seeing it practically play out every day, which is really cool to see. And what this really does for us is actually quite a number of things in the IoT world. We can reduce bandwidth by not having to send as much data up to the cloud, and not having to send power or data over our Wi-Fi antennas or cellular antennas. Actually ends up with lower power. We get lower latency, faster results from our models. And the less data we're sending up to the cloud, the more security and privacy we're going to see. And then for safety critical applications, obviously not having to rely on an internet connection is awesome. So this has been a pretty cool trend to watch, and I think it's something that we're going to see more of as time goes on. So with that kind of background of sort of machine learning fundamentals and sort of where it fits into the IoT space, we're really coming to the big question, what makes a machine learning project successful? And I think, like I said, there's two big categories here. There's business contributors and there's technical contributors. So if you're more on the business side and you get excited about these things, just know the technical stuff is still really important too. But if you came here and you're really technical, you're like, oh, business contributors. That's all right. We'll get to the technical too. But what we've found over time with a lot of different customers is that if we're not thinking about both sides of this equation, both the business side and the technical side, that's a really good way for a machine learning project to fall on its face before you ever get started. So I'm going to jump into the business side. And the first thing I really want to highlight is business value. If you're walking into a machine learning project and you don't really understand what the value is to your end customer or the value is to your business, if you don't actually have a use case there, things are going to fall apart really quickly. It might be really cool, it might be really awesome, and it might be really exciting, but if there's not value for you, it's not going to be a good business model. So if we look at a couple of different use cases or examples of this, one that I threw out there was just this idea of a smart toaster. Like let's say you're a person that's super passionate about toast, and you hate when your toast is not toasted just right, or gets burnt, or is maybe more brown on one side than the other side. So you think, you know what, I could use machine learning with some computer vision. I could target where the heat elements are on and off so that I can get just the right toast. And maybe you're super passionate about toast. That's great. But a smart toaster like this is going to cost a lot more. So let's say there is actually one of these out on the market, but it costs $300. So you really have to go through that market research and see if there's enough people out there willing to pay $300 for a toaster that's going to make them perfect toast versus a $30 off-the-shelf dumb toaster. And asking those questions up front is really important. Or if you look at a totally different industry and say an industrial use case where you think, this preventative maintenance thing is awesome. I want to prevent downtime in my manufacturing process. So I'm going to implement these machine learning tools to do that. That's awesome. The thing to keep in mind is trying to get an idea of how much that machine learning development time and implementation is going to cost. Does it really add value at the end of the day if your downtime events are only happening once every 6 months? That's a question you have to wrestle through to know if it really makes sense to implement this or not. Oftentimes it does, sometimes it really doesn't, but knowing it up front makes it much easier to have a successful machine learning project. The next thing I want to touch on is the right knowledge. We've all heard the old adage that knowledge is power. That is absolutely true in this machine learning space. There's so much to learn and so many terms and so many things that we need to understand to get a feel for how machine learning works, how it's implemented, how we make money off of it, what tools are out there, what frameworks are out there. And there's a lot of great training resources that exist. But if you don't come into a machine learning project understanding what it is, what its limits are, what its capabilities are, you're almost guaranteed to have that project fail. Another thing that's often overlooked is this organizational buy-in piece. You think about a lot of other technology frameworks. If you just think about a web framework like React, most developers are going to know what React is. Many people in more of the business world might have no idea what it is. AI and machine learning fall into this weird space where almost everybody has heard of it. It's all over in our culture, in our movies, and it's on TV and news articles. And people have a lot of different preconceived notions of what exactly AI is. Some people think it's super exciting. Some people think it's just hype. Some people think it's scary. But if you could come up with a great business plan and you could come up with all this great technology, but if you run into somebody in your organization who's a key stakeholder or somebody that has to sign off on your budget and they don't believe that machine learning is something that your business ought to be doing, you're going to be dead in the water again. So how do you get that organizational buy-in and have everybody in your company or organization really be on the same page with wanting to implement machine learning and really knowing what it is? The next thing I think that is really important is this idea of realistic expectations. There's a lot of belief out there that AI is just a silver bullet. It's going to solve all of your problems. You just give it your data and it solves all the problems for you. Sometimes maybe that's true, but that's rarely the case. So being able to know what can you realistically expect as an organization? What can you actually implement? So I have a slide here that kind of gives this big time and money funnel. And this is what I like to talk to customers about when they start thinking about implementing their own machine learning project from a business perspective. You could look at something like a Tesla where they have a self-driving car, and maybe you could think, I want to build a self-driving car. Well, if you think about all of the different inputs that go into training machine learning models to be able to do that self-driving, there's a ton of variability in your inputs. There's a lot of different things that can happen, a lot of different control mechanisms that need to be taken care of. There's also a really high safety risk that comes with this. If something goes wrong with your machine learning model in a Tesla, that could be somebody's life. Where if you kind of move all the way down to the lower right of this funnel, I have a classifier for my two dogs that I have at home. I have a Husky Golden Retriever mix and my Beagle Zeppelin here. And in an hour in an afternoon, I grabbed a few images of them, trained up a model to be able to load onto my phone where I can take a picture of them and it tells me which of my two dogs it is. That's a very low time, very low money investment, and there's very low risk to it. So as you start talking about sort of what's realistic for your size of organization and the amount of time that you have and the amount of money that you have, there's just a lot of these factors that come into it. The safety risk side of it, what happens if your model is wrong? How big of an input variability do you have? Think about this blueberry classifier in the lower left. This is something we built to help farmers get an idea of when to harvest their blueberries. So in this one, it counts the number of blueberries on a bush, tells you how many are ripe, how many are not ripe, how many are overripe. If you think about building something like this didn't take a ton of time and money to do. But if you wanted to build a generic classifier that did this for all different types of fruit, all of a sudden that time and money investment goes way up from where you were at before. So just starting to think through, like, how big of a problem are you trying to solve? How much data needs to go into it? And what's the risk factor if things don't go well? Those are all key important things to remember when you're thinking about how realistic your problem is. Then the last piece that's often overlooked on the business side is this idea of continued investment. When you think about any sort of IoT solution, once you deploy it out in the field, there needs to be regular security updates. You need to maintain your cloud infrastructure. There's a lot of work that goes into keeping an IoT product running. In the same way, machine learning is very similar, that there's oftentimes retraining of the model. There's new inputs that you didn't realize before that need to be accounted for. So you need to be able to retrain your model, redeploy new things, gather more information, and see how your model's functioning. It's not just a linear timeline where you get to build a dumb toaster, you ship it out to stores, people buy it, and then you're done. This is something that requires some ongoing investment. And if you don't think about that from the business side up front, it can cause a lot of headaches down the road. So that's kind of the key business contributors. If we jump over to the technical side, there's quite a few things that we could cover here. I'm going to hit sort of these top 5 that I think are probably the most important. And the first one that people often think about is the technical talent and the resources. Who's actually in my organization going to do anything with this? Do I have to go out and hire a bunch of PhD level, super smart math geniuses to be able to do machine learning? Well, sometimes yes, but not always. But there's a lot of different things that we need people to be able to do as part of this process. And it takes a team. It's not just one person. So if you think about some of the important roles as part of this technical talent, a big part of it on the front end is the market researcher or an industrial or process engineer, somebody who can really help you establish the value of your idea, build a business case, and then use some of those business intelligence tools to figure out if your idea really makes sense, really has value. And then you still need software developers. So my initial slide that I showed about traditional versus machine learning development, you may have noticed that the machine learning didn't have a developer in there anymore. Well, in reality, there is actually still software developers there. They're the ones writing the data processing code, some of the model code. They're also the ones helping figure out how you deploy and monitor these models, as well as sort of this ML ops piece. If you've heard of DevOps in the software world, ML ops is really similar. How do you swap in new models? How do you get new weights out to your devices or out into your cloud and do that in a continuous and testable and safe fashion? So along with software developers, oftentimes you need some sort of data scientist or somebody who really understands data mining and analysis, how you get clean data, how do you evaluate your models from a statistical perspective and prove that one model might be working better than another one. And then at the end of the day, we also need people that really understand machine learning. Somebody who can take your data see the type of problem you're trying to solve and know what sort of model would work to try to solve that kind of problem. They're also going to be able to help do the training and tuning of your model as well as data augmentation. So if you think about, or this idea of data augmentation is basically taking your inputs, all this data you've collected, and saying, I'm actually going to artificially expand that because I know I didn't capture all of my inputs. So you think about something like the blueberry classifier that I showed. You could go out and take a bunch of pictures of blueberries, but you know in your mind that there's going to be different levels of brightness. You know, it might be sunny, might be cloudy. You can actually take those images and artificially brighten and darken them, and that actually get a lot more data going into your model at a much lower cost. And machine learning practitioners tend to know good ways and approaches to do that realistically. And so you look at this team and you say, wow, that's really daunting. How do I hire all of these people? Sometimes it's not hiring, and sometimes one person can fill multiple of these roles. I would strongly encourage anybody moving into this space to do a lot of in-house training. Somebody that has a lot of domain knowledge of your specific context that can learn some of these skills outside of their normal role can be really, really valuable in getting machine learning projects up and off the ground in your organization. So along with the technical talent that you need, you also have to have processes. There has to be an approach to this that's repeatable, just like we've learned how to develop software, we've learned how to develop machine learning models. And oftentimes it looks like this really circular process. So up in the upper right, if you just look at sort of this blue circle in the middle, you end up in kind of this project design phase. This is where you're gathering your initial data, trying to establish a business case, figuring out what sort of data you would need to actually solve that problem. And once you kind of figure out those pieces, then you can move into the data preparation stage, where oftentimes a data analyst can go in and do some initial understanding of your data to see if you actually have everything that you need there, figure out what features might matter, how can you augment that data to get more value out of the work that you put into the initial data gathering. And then you actually get to go into the part that I love, which is the model creation and training. So you get to take the data and your expected outputs and start training a model and see how good you can get it to work. And then figure out where you want to deploy that model. Do you want to host it in the cloud? Do you want to run it on your edge device? There's a very different approaches to how you do that and how you go about that process. And once you actually have a model created, then you get to deploy it out in the field and start gathering more data on field accuracy analysis, gathering more data so that you can refine your model, retrain it, and see if you actually achieved the business value that you were hoping for. And sometimes this process is linear, that you can actually gather data, train a model, deploy it, and be done, but that's rarely ever the case. And it's actually rarely the case in typical IoT products. If you think about a good example like a Google Home, something where you're using these voice commands to interact with this device, there's a lot of machine learning happening on the back end to do that natural language processing. But Google didn't go through, deploy voice, and then move on to something else. They're continuously refining this voice model and gathering more data and making it better, listening to user feedback, and then they're deploying updates and deploying updates and deploying updates. It's an iterative process that really leads to a better overall end product and a better overall user experience. But understanding this up front, how those processes work is really important. And then I'm going to really highlight this because it is so important. Good data. Really knowing that you have quality, well-labeled data coming into your machine learning training is so important. There's a famous quote by Thomas Redman. It said, if your data is bad, your machine learning tools are useless. And I've seen this personally over and over and over again, where bad data leads to bad models and a lot of confusion and a lot of wasted money. There was actually a study done by IBM a number of years ago, and they estimated that low quality data cost businesses a total of $3.1 trillion a year just in the US. So good data is so important. But if good data is important, well, what is bad data? There's a lot of different things that can contribute to that. Sometimes it's just a bad signal to noise ratio. We had a case of this in a project that we were working on where we were doing some 3D computer vision analysis, and the actual thing that we were looking for in our depth data was so small compared to the noise that we were getting from our device that we couldn't really train anything that was worthwhile. We had to go back and revisit some of our hardware. Occasionally, you can get really imbalanced data sets. If you trained your blueberry classifier on all ripe blueberries, then it might have a really hard time recognizing underripe ones or overripe ones. Not covering your input range is actually really similar. You could have trained your blueberry classifier to look at a bunch of unripe and then ripe ones, and never actually showed it any overripe ones. Now a farmer goes out and he keeps taking pictures of his blueberry bushes, and all of a sudden it says, "Hey, everything's ripe." And then he goes to harvest and everything's rotted and falling apart. That's a really bad user experience. I would hope most blueberry farmers would notice that, but this kind of gives a toy example of how if you aren't covering all of that expected input range, you can create a model that really isn't that great. And then ultimately, mislabeled data is probably the most common one that I see, that you end up in a case where you thought your data was labeled correctly, and then it wasn't, and it caused your model to start being really confused about how to arrive at a conclusion. So if you think about my dog classifier, if I had been taking pictures of my dog, Pascal and Zeppelin, and then swapped them out, and then gave the model and said, "Here, these are all Zeppelin, and some of them are Pascal and some of them are Zeppelin, and then the other ones are the other case," your model is going to really struggle to come to a conclusion because you didn't tell it the right things to do. A couple other bad data scenarios that exist out there. If your input data is biased, this is actually something that has happened quite a bit, especially with like automatic loan processing, where they used a bunch of loan processing data that actually had racial bias built into it, and the model was trained and learned from those bad biases that came from the input data. Something we need to be really careful about as we get into the machine learning space. Understanding what your input data's limitations are, all of those limitations are often going to get transferred right into your model. Sometimes our machines just learn bad behavior. There's actually an example of this that was not great, but Microsoft released this chatbot out. This was a number of years ago now, and they wanted to show how unsupervised learning could work, how they could take this chatbot, put it out in the wild and let it learn from human interaction, and hopefully it would get better at human language by learning from it. Unfortunately, they decided to release this chatbot out on Twitter, and Twitter unfortunately didn't have the greatest training sets for how humans ought to communicate. And Tay actually learned a lot of really bad behavior from that. Microsoft had to pull the plug, and it was not good from a public relations standpoint. The good thing that came out of it was that Microsoft has actually now done a lot of leading in the ethics space of machine learning to make sure that we're putting right boundaries and protections in place for things that we deploy out for machine learning models. Other times there's just human factors that are missed, things that we made assumptions that weren't true, and that can impact how our model learns. The next thing I want to touch on is this idea of a realistic problem and solution. So we talked about realistic expectations from the business side. When I talk about realistic problems and solutions from the technical side, this is where we start to get into a little bit more of the weeds of trying to understand how inputs can affect outputs. So as an example, let's say you wanted to create a wearable consumer device that could detect the types of allergens in the air and help your user know when to avoid being outside when there's really heightened allergens in the air. And you make this awesome wearable device, and the only sensor you put on it is a microphone. Well, microphone is probably never going to give you any sort of realistic information about allergens in the air. So you need to be able to at least have some understanding of how your input data can arrive at a solution. Now, maybe your microphone would do a really good job of detecting sneezes, and you might get a good picture of how bad allergens are at any given time, but you wouldn't be able to say which allergens are what. So being able to have some sort of way to explain your problem and explain your solution, there's a lot of magic that kind of happens under the hood of machine learning, but we have to never forget that it does tie back to the real world, and that oftentimes we should be able to explain how our model might have arrived at a specific solution given those inputs. Then the last one I want to touch on is the right tools. So this part is really important from a developer standpoint. This is where I spend a lot of my time because the tooling that you choose and how you go about gathering data, training, writing your code for it, deploying things out really has a big impact on your overall budget and scope and even what technical resources you need to hire. One thing that's really interesting when you look at machine learning as a whole, just within the global machine learning market space, these were some projections from Forbes a while back that kind of showed the amount of spend in different categories of hardware, software, and services around machine learning from 2017 up to 2024. And you can see this graph is showing just a constant increase, and it's not getting any slower. We're continuing to see more and more money being spent in this space, both on the devices that are actually running the models, on the software that is being written to process them and deploy them and make it easier, and then even on the service side where you're hiring people to come in and help with these machine learning model services. This is awesome to see the growth, but anytime you have these types of numbers and this much money being spent in this space, there's a lot of companies clawing for this market value. So one thing I really like to tell people is to really beware of machine learning snake oil. There's a lot of companies selling products that sound awesome, that we can come in and solve all of your issues for just this small fee. And oftentimes those end up being completely unrealistic. So being able to do some of those things on the business side, gathering the right knowledge, helping to know what the terminology is, and understanding some of the basics of the technology can really help avoid some of these things. There's a lot of money here. There's a lot of great players in this space. There's other ones that maybe aren't so great. And being able to know what's important for you as a business can be really, really a key to successful machine learning. And even asking some of the questions early on, if an organization is coming in and trying to sell you their product, asking some of the questions like, at the end of this, who owns the code? Who owns the data? Who owns the model? If it's not you as the customer, there's probably some bigger questions that you need to ask about how this product actually works. So when we start looking at some of the tools that exist, I'm going to break this up into 3 big categories. There's a lot of tooling, even different languages and development environments. But at the beginning of these tools, I would say there's frameworks for doing machine learning. And these are mostly going to be implemented by developers in many different ways. But you don't have to jump into machine learning by hiring somebody to go write all of these complex math functions. All of that work's done already by a lot of other companies with a lot of open source or closed source frameworks that you can leverage to really help accelerate things in a much faster way, which is awesome. It has changed the landscape and made it so much easier to get into this machine learning area. Then if we talk about kind of this next step, there's sort of this machine learning as a service tooling that exists out there in all sorts of forms. Some of those can be completely black box. You just give a company data and they give you a model back and you hope that model works. Other times we have a lot of cloud providers like AWS or Microsoft Azure or Google Cloud Platform that are really trying to make it easier for you to leverage all of their existing hardware and software platforms to just accelerate the development. Obviously that comes at a cost. These things aren't free, and so you're essentially paying for the ease of use, that you don't have to actually go and build your own high-end training server. You can leverage what already exists out there in the cloud. There's another one I have on here, Edge Impulse. This is a platform that we use occasionally that really helps accelerate machine learning models that are going to be deployed on edge devices. So really their specialty is saying we're gonna make it super easy for you to bring in your data, train your model, and then deploy it to small microcontrollers or WebAssembly or just out to C++ code that you can implement wherever you want. But figuring out what types of providers are out there, what types of partners you can use, what types of services you can leverage to accelerate it in your business is really, really important. You can save a lot of time, save a lot of money, but you also need to be careful. Then on the last side here would be more of the partners side. So you don't always have to have all of the expertise in-house, especially when you first start out. You can leverage other partners as part of your machine learning process to start getting up to speed, and eventually, as you do more internal training, you might be able to take over more of these types of services. But leveraging partners is a really good way to start. I threw a couple different ones on here. Amazon Mechanical Turk is actually one that can do a lot of data labeling for you for really cheap. So if you don't want to pay people to sit and label data and say, yep, that image is a dog, that one's a cat, you can leverage a partner like Amazon Mechanical Turk to help with that. Then you have companies like SpinDance, shameless plug. We're going to be more on the software side, helping to assess what's feasible, what's possible, helping to architect what types of models you might want to use, how you might want to train and deploy them. And again, this can just be used as sort of a stepping stone until you get your own technical resources in place to own more of that process. Then you can also find partners on the hardware side. Now, if you want to be able to run your device on the edge, you need to be able to have the hardware that's actually capable of that. So a partner like NVIDIA might be able to come in and help you find the right board option that gives you the horsepower you need without spending ridiculous amounts of money for it. So figuring out the right tooling is hard. There is, like I said, a lot of snake oil out there. There's a lot of companies providing sort of these off-the-shelf solutions that sometimes are great, and sometimes I look at them and say, there's either no way that's even possible, or I can't believe I don't get anything out of this except a model, and you actually own all of my data. That's a problem. So just be careful, but leverage the tools that are out there. It accelerates these projects a lot faster. So from a high level, that's really what I see as the major contributors from both the business side and the technical side. All of these things are important. It takes a lot to get them all figured out, and I would say it takes time, and that's okay. You want to come into a machine learning project armed with the right knowledge, the right understanding, the right tooling, but being able to understand the things that make a project successful or not is a really good place to start. So the real question then is how do you assess your readiness? If those are the contributors, then how do you actually go about figuring out for your business what matters? And I just kind of put it here as a number of questions that you can ask. These are starting points. Again, if there's specific things on those contributors that are like, man, I really have a question about what that looks like. Again, feel free to drop it in the chat here. We're going to have some Q&A time here shortly. But these might be some good questions to ask yourself, and write these down or take a screenshot or whatever it is. But starting out with asking the question, can you clearly state and support your business case? Now, if you can't, then take a step back and figure that out. What knowledge are you missing? Are there terms that I threw out today where you're like, Ben, I have no idea what you're talking about? That's a good sign to say, you know what, maybe I need to go do some searching and maybe do some training to figure out what that looks like. Do you have a budget for training? There's gonna have to be some time spent on learning, whether you're hiring outside people to do it or not. Being able to get that knowledge in-house to understand what this is important. Do you have money set aside for it? Remember, this is an investment. Are all the key people in your organization on board? And if not, why? Why not? And how can you help convince them that there really is value here? And are your expectations realistic for the size of your business? If you're a company of 5 people, maybe building a self-driving car isn't the right option for you. But figuring out what is realistic for your business, what can you tackle? And can you list out the pieces that are going to require continued investment and figure out what that looks like? From the technical side, what people or skills are you missing to fulfill on every part of that machine learning process? Sometimes it's easier to just list out the skills. Maybe you have people that have some of those skills already, but it's sometimes easier to identify the skills and then go find the people that match those skills rather than just say, I need a data scientist. Well, you need a data scientist for what? Try to figure out what that looks like. And do you understand the processes that are needed? You don't have to actually have them all in place yet. Just knowing what they are is a huge good place to start, where you can know this is how a machine learning process works, and I'm going to be prepared to know how to do that and how to do that well. And do you understand the need for good data? And how would you define good data in your context? Everybody has different data that they need, different outcomes that they're trying to come up with, but how do you look at that? Then ultimately, what tools or services are available that might accelerate your solution? You don't have to go in and build up all of these math functions from the start. Can you leverage some frameworks? Can you leverage some platforms? Can you leverage some partners to help move things along more quickly? Now, I would just say, don't be afraid to start small and to start low risk. You can do a smaller machine learning project before trying to bite the bullet on this gigantic one. But really taking the time to get your feet wet, figure out what's possible, start low risk, and figure out what pieces of your process you're missing or what knowledge might be missing from there. So that's kind of the end of our content. I want to take some time now to start an audience poll. And really, I'm curious for this audience here, what is the largest barrier in your company to implementing a machine learning project? Is there something holding you back that really is causing things to stumble or to fall? Is there, or you're just not sure? You're just like, oh, this is interesting, this is cool, but I have no idea even where to begin. We're going to take a few minutes now to just kind of answer that poll. Then we'll share it with you guys, just kind of showing some percentages of what's there, and we'll talk to how to maybe overcome some of those barriers. And again, if you have specific questions about them, feel free to drop that in the chat, and we'll have some time here shortly to go over some of those questions. I know for me, starting out as I was working in a couple of different companies in the machine learning space, there was a lot of barriers that I ran into. And looking back and seeing them now, I have a much better understanding of how we could have overcome them earlier on, or kind of cut things off at the pass. So poll is in, and looks like the majority is just unsure where to start, which is very, very common. A lot of people are also saying no budget available, which is also one that's very common for us to see as well as the lack of in-house expertise. Those are big barriers. And yet, at the same time, we know that all of those barriers are overcomable. Companies are doing this; they're seeing the benefits, they're seeing the value. But hopefully, as we talk about more use cases, those will answer some of those questions of where to start. All right, with that, we are going to turn over to a Q&A time.
Well, thank you, Ben. That was very interesting. I'm more on the engineering side, so I never think about the business side, or rarely. But that's the technical side is just one part of getting over the hump to get something working. You have to think of the business side as well. So now it's time for our Q&A session. We've received some excellent questions, so I'm eager to hear what you think about them, Ben. So first one, and you did mention this, you covered this right at the beginning of the presentation, but somebody's still asking, just in general, how do you distinguish between the terms machine learning and AI, artificial intelligence? And this is, I mean, this is like the real fundamental starting point, but everyone gets confused over it.
Yeah, it is. It is confusing, partly because people use the terms so interchangeably often. And really, when you think about AI, that's the big category. Anytime that a machine is kind of acting like a human, acting like it's thinking like a human, that's the big, broad set of artificial intelligence. And that's often what people think about. That's often what gets captured in our culture, in our movies, in our media, is this idea of a human or a machine thinking like a human. Yeah. Then machine learning is the space I like to talk about, where you're actually taking that down to a practical, statistical approach that you can really write code for and develop models for. So I like to think about machine learning as sort of the practical application of artificial intelligence, if that helps. But yeah, it's a great question, and one that brings a lot of confusion.
This is one for me actually, does machine learning always involve artificial neural networks?
No, sometimes it can actually be just some really simple statistical models that you're training. There's other types of models that don't require neural networks at all. You could have just some basic logistic regression type equations that fall into that statistical machine learning type space.
Cool. Okay. All right, this is a good one. Is there any way to get a sense of how much effort a machine learning project is going to take? How do you estimate it?
Yeah, how do you estimate it? That is such a good question. So there's a couple of things that I always like to think about, which is, what kind of data are you capturing, and can you actually find some similar data out there in the real world? This is an area where I love to say, go see what you can find first. If you can find an existing data set out there that is similar to the type of problem you're trying to solve, that can save a huge amount of time on the front end of having to gather and label that data. There's a lot of time and cost associated with that. So if you can leverage some of those existing pieces, that can really accelerate you to figure out if what you're trying to accomplish is feasible. But trying to estimate how much time a machine learning project is going to take is hard. It's definitely not always a science. But when you start looking at how variable is your input data, how good does your model have to be? Some of those types of questions help narrow down that estimation scope. Oftentimes with machine learning, you can get a model that goes up to 80, 90% accuracy really easily. And then that last 5%, that last 4%, that last 1%, it's almost an exponentially increasing effort to get to that level. So depending on how accurate your model needs to be, that can be a big impact on your estimation as well.
Right, and I think one thing is also accepting that there's a lot of variability in this. I saw a quote recently that said, you might get a model that says, I'm 98% confident this is a chicken. And then, or it might say 96% confident this is chicken. The bottom line is it's a chicken. Don't worry about that percentage.
Yep. Yeah, there's some cases where that percentage is far less important. There's other cases where it's really, really important.
I think one thing about this is if you want to estimate something like this, this is where the partners come in, like Spindance,
Yes.
who actually have done this before and can look at the problem and go, that's a weekend's work, or I'll see you in 3 years.
Yep. Yeah, that it's just like any other type of estimation project. The more you do of them, the better sense you get of how difficult it is and what the scope of work would look like. So it's nice to be able to leverage somebody that has that experience, and it's hard to get that experience on your own if you've never done it before.
Anything you do, when I'm writing a white paper or something, years of experience have told me how to guesstimate for the particular project. You can't just say every white paper will take 2 days. It depends on so many factors.
Yep, that is very true.
Question here. Many of us are hiring ML services, machine learning services, via a customer-facing dashboard platform. For example, AI-assisted language translation services. In this situation, how does the customer do due diligence and ongoing compliance assurance with regard to the provider's model quality?
Yeah, that is a great question, and one that I think even the fact that you're asking that question makes me so happy that as we look at some of these model providers, it so much of it falls back on the end user, the customer who's buying these services, to really validate that the services are working as well as they say they are. So some services will have some tooling built in to give you a sense of how good your field accuracy is. But sometimes there's no better approach than just a boots on the ground, surveying your customers, doing some research on your own to validate that those services are working as well as they claim they are. It's not always easy. It's not always cheap. There's not a magic bullet where you can just say, yep, I'm going to do this and it's going to prove that my model is working awesome. There's just a lot of legwork that comes with it, but it's worth it to be able to validate that the service is doing what you're paying for.
Yeah, sometimes finding other people who've used it and talking to them if they'll talk to you.
Yeah.
I mean, like for me, if I'm buying something on Amazon and I've got 4,000 positive results, that gives me a lot of confidence that it's worth spending the money.
Yep. Yeah, that's
Yeah.
a great way to analyze things.
Okay, before I invest a bunch of money in a machine learning project, I guess, is there some way of knowing how likely it is to succeed?
Yeah, I mean that is a big question, and something that a lot of customers come to us with, where they want to say, I'm not ready to drop, you know, $200,000 of development time on this until I have some level of confidence that this thing is actually going to work. And so a lot of times what we'll do is do some small pilot proof of concept type approaches, where we'll take a limited amount of data set or try to solve a limited portion of the problem to show that the capability is at least there, that you have the right data to arrive at a conclusion with some level of confidence. And then you kind of build it up from there. That's one of the cool things about machine learning, is you don't have to build the entire thing right from the get-go. You don't have to build the entire development stack like you do with some projects. In this case, you can start small, iterate on it, add more classes to your model, add more input variation in, and build that over time. And you're going to see pretty quickly whether you're on a trajectory of this is looking pretty successful, or this is really going downhill quickly. And again, if you can leverage existing data sets to do those initial proof of concept pieces, even better, because then you can get started really quickly.
And if you build your own data set, then you've got a valuable commodity there to sell to other people.
Yeah, that's actually becoming a whole new market space where customers are finding, there's all of these open source models that they get to leverage. So their secret sauce isn't necessarily in their models. A lot of companies are finding that their secret sauce is in their data. So
Right.
they can either hold that data close to the chest, or they can actually find a new revenue stream with quality labeled data, which is interesting.
Yeah, which something to keep in mind at the beginning. Do you want to create your own data set with the possibility of selling it on later, or do you want to buy somebody else's? In
Mhm.
which case, you've got to do some due diligence to make sure the data is of a sufficient quality.
Yep. And I would
Because
also caution people to always look at what licenses are being used on data sets. Sometimes there's a lot of them that are licensed for research purposes, but not licensed for commercial use. So be careful and read your licenses.
right, because you can't just say, "Well, I did the research and now I've gone commercial."
Yeah, yep. People have tried that approach.
Okay, speaking of data, when you're starting out on a project, how do you know how much data we will need to make a good machine learning model?
So a lot of that again comes down to your input variables and how close some of your different types of things that you're trying to look at are. So again, if you think about my dog classifier as a great example, I'm only trying to look at two different things with my classifier, and they look very different. A beagle and a yellow dog have a lot of differences between them, and I'm only ever expecting my model to see one of two different things. So as you take that and then scale it up to something like a Google Home device that's listening to words, there are so many different inflections and accents. Max, you and I sound a lot different, even though we're speaking the same language. And being able to figure out how you can gather enough data to work across all of those use cases is an important step. So just trying to think about it from a big picture standpoint, how would you capture that data? If you're processing image data, how many different variations of a fruit would you need, or how many variations of a human or a person or a dog, whatever it is you're trying to classify? Being able to put that into perspective of what problem you're actually trying to solve. Trying to say, I just want to create a classifier that can tell what everything is in a picture is way different than trying to say, I'm trying to look at a difference between two dogs.
Right, and I think a lot of people fall into the trap of thinking that this is all to do with vision,
Yes.
object detection and recognition. But in fact, machine learning appears in all the examples you were talking about earlier on, industrial control systems or monitoring motors, pumps, other things that may not necessarily involve vision. So another aspect to this is, what sensors do you use? Because some people have knee-jerk reactions. Let's throw a camera into the picture.
Yep.
But that might, if you're trying to detect if an engine's vibrating, I mean, if it's vibrating inches off the floor, the camera's a good idea or would work. But there are other sensors, and some people automatically say, oh, let's throw a 3-axis accelerometer in. But it might be that using a current sensor can provide just as much information or for the task you're looking for, because you can overwhelm the model with too much data.
Right. Yeah, that's a great point. This is one space that is just so cool that there's so many different types of sensors. Cameras are so easy to grasp because that's how we process so many things. It makes really good examples in a presentation like this.
Oh
But
yeah,
audio data is another one where you can detect things like glass breaking. I did a fun project last year with a little Arduino Nano, where I have a window air conditioner in my house that would sometimes get clogged, and the motor in the back would start flinging water all over my house. And I remember sitting down at the table one day and I could hear it immediately that it was clogged. And
right.
so I thought, man, I wonder if I could train a model with a microphone to automatically detect this for me and send me a notification. So I took my little Arduino Nano with a microphone on it and put it next to my air conditioner and trained it to learn for clogged drain holes. And so being able to think about audio data or sensor data, like you said, current sensors. We did a project not that long ago with something that was trying to detect certain types of human activity. And we actually used 2 super cheap PIR sensors, or infrared proximity sensors. And depending on where a person was in relation to those sensors, we could actually train a model based on their inputs to detect what type of activity a human was doing.
Hmm.
Way cheaper than you could ever do with a camera. And it
Yeah, yeah.
increased the privacy of the system, which was awesome.
Well, I've done a lot of work in industrial environments where you can be walking through a shop floor or a factory floor with an old, experienced engineer, and you're just walking down between tons of machines. I mean, it sounds like a cacophony of sound, and, and he'll stop and go, "There's something wrong." And
Mm-hmm.
somehow, out of all that sound, he can pick out there's something wrong, or just putting his hand on the machine as you go by, and he feels the vibration. And being there for years, he can tell when there's something subtly wrong with the vibration, and he
Mm-hmm.
stops and pauses and goes back and has another look. Yeah, so like you say, audio, vibration, all sorts of things.
Yeah, it's amazing how you can start to pick up on some of those patterns, and just like we learn those things as humans, that's
Hmm.
what's making machine learning so powerful. It's picking up on a lot of the same types of cues that we do, and being able to turn that into something that's reproducible. It's you can't easily reproduce an engineer with 20 years of experience that can pick those things out. But if you can start training a system to be able to do that, all of a sudden you've brought a lot of value in.
Oh yeah. Especially in the case of industrial control, where you've got the same motor replicated 1,000 times, then you get the data from all of the motors, and one that fails in an unconventional way with the bearings or something, uh, then you just get similar vibrations on another one around the world, but you've seen that pattern before somewhere.
Yep.
Of
Yeah,
course,
there's a
that
lot.
then goes to a whole another level of analysis in the cloud and things.
Yep.
Well, I think we've got time for just one more question here. And while I ask this question, Ben's told me that you can feel free to contact him directly using the contact details shown on the screen. So, which one do I pick?
It's always the challenge.
Um, okay, well, actually, this is one that's close to my heart, and again, it goes back to the business sort of thing. Do you have any recommendations on how to get other people in my organization on board with the idea of machine learning? And I can imagine me running around going, "Look, this is great, this is great," yeah, and everyone going, "We don't know what it is." So how would you do that?
Yeah, that's a good question too. Some of the things that I love to think about is first to put myself in that person's shoes. I love technology. And so the thing that I jump to right away is I'm going to show you how technologically awesome this is. But for many people, that doesn't matter at all. So if I
Hmm.
put myself in the shoes of somebody who's a financial controller, they're going to be way more interested in the business value. And so if I can start bringing them some use cases and tell the story from different perspectives, all of a sudden that can really start changing some minds. But it takes some empathy. It takes some time of putting yourself in those person's shoes. Sharing use cases is awesome. The more types of use cases you can share from those different personas, the more you can start to get some of the people on board. And the more you learn, the more you can address and answer some of their concerns and questions as well. A lot of listening.
Yeah, that makes sense, because like you say, I'm always bouncing around going, look how cool this is, and they don't care. Yeah, but whereas if you say, yeah, you can cut your energy expenditure by 50%, suddenly.
Yeah, all of a sudden you got a believer.
Yeah. Okay, for those of you who submitted questions that weren't answered, we're going to forward them to Ben, and he'll respond to you by email. And I'm afraid we've run out of time, so this brings today's webinar to a close. I'd like to thank everyone who joined us and viewed the webinar. I'd like to give special thanks once again to Spin Dance for their sponsorship, and especially, of course, to Ben for his insightful presentation. Once again, this is Clive Maxfield, and I'm very pleased to have been your host for today's event. I look forward to seeing you all again on the next IoT Central webinar. And until then, from all of us here at IoT Central, we hope you have a wonderful rest of your day.